Hi everyone, today we're going to look at solving radical equations. As a reminder, radical equations are equations that contain variables inside the radicand. Remember, the radicand is the expression underneath a radical symbol. These are three examples of radical equations. The square root of 3x plus 18 equals x. The cube root of x equals 4. The square root of x plus 5 minus the square root of x minus 3 equals 2. Radical equations may have one or more radical terms, and they're solved by eliminating each radical one at a time. We have to be careful when solving radical equations, as it is not unusual to find extraneous solutions, roots that are not in fact solutions to the equation. These solutions are not due to a mistake in the solving method, but result from the process of raising both sides of an equation to an even power. Consider the following. When you raise a number to an even power, whether it is the second power, fourth power, or even the 50th power, you can introduce a false solution because the result of an even power is always going to yield a positive number. Think about it. 3 squared and negative 3 squared. They both give us 9. And 2 to the fourth, as well as negative 2 to the fourth, are both going to yield 16. So when you squared negative 2 and got 4 in this problem, you artificially turn this quantity positive. Therefore, when the index of a radical is an even number, such as when the index is 2 for a square root, 4 for a fourth root, you will need to verify that any answers obtained actually work. This can be accomplished by plugging the answers back into the original equation to see if the resulting values satisfy the equation. It is also good practice to check the solutions in the original equation when there is an odd index to identify any algebra mistakes that could possibly have been made. Here are the steps that I want you to follow when given a radical equation and asked to solve it. Step 1. Isolate the radical equation on one side of the equal sign. Put all remaining terms on the other side. Step 2. If the radical is a square root, then simply square both sides of the equation. If it is a cube root, then you're going to raise both sides of the equation to the third power. In other words, for any nth root radical, raise both sides to the nth power. Doing so will eliminate the radical symbol. Step 3. Solve the remaining equation. Step 4. If a radical term still remains, I want you to repeat steps 1 and 2. And then finally, step 5, confirm your solutions by substituting them back into the original equation. If you plug them back into the original equation and they work, and they give you a true statement, then you will count that as a valid solution. If you plug it in and it gives you a false statement, then you will consider that an extraneous solution and omit it from your answer. Let's begin by looking at example 1, solving an equation that contains only one radical. Square root of 15 minus 2x equals x. Notice that the radical is isolated. To get rid of that radical, I'm going to go ahead and square both sides. And when I do that, I get 15 minus 2x equals x squared. Now we have a quadratic equation, and in order to solve a quadratic equation, we need to first move all of our terms over to one side. So you're going to want to move everything over to the side that makes x squared positive. So in this case, I'm moving all of my terms to the right side of the equation. And I have 0 equals x squared plus 2x minus 15. I can go ahead and factor this. To get x squared, it's x times x, and I need two numbers that multiply to negative 15 and add the 2. So positive 5 and negative 3. And then I can set each of these factors equal to 0. And I get x equals negative 5, as well as x equals 3. Now, unfortunately, this problem is a square root problem, so the index is even. So that means there is potential for extraneous solutions, so I do need to check my answers. Let's start by checking negative 5. So I'm going to plug negative 5 back into my original equation for x. And we get 15 plus 10, which is 25. And we know that the square root of 25 is 5. which does not equal -5. Since this was a false statement, x equals -5 is not a good solution. It is extraneous. Let's go ahead and check our second answer, x equals 3. Again, I'm going to replace x with 3 in my original equation. 15 minus 6 is 9. Square root of 9 is 3. So this one is a true statement. X equals 3 is a valid answer. Let's go ahead and look at the try it on your own. For part A, I have the square root of x plus 3 equals 3x minus 1. Notice the radical is isolated on the left-hand side again. So to get rid of that square root, I'll square both sides. And I get x plus 3 equals 3x minus 1 squared, or 3x minus 1 times itself. We can go ahead and FOIL the right-hand side into 9x squared minus 6x plus 1. Since we have another quadratic equation, let's move all of our terms over to the right-hand side by subtracting x as well as minus 3. 9x squared minus 7x minus 2. And I can go ahead and factor this into 9x and x, 2 and 1. And it's got to add a negative 7x, so I need it to be a negative 9x, a positive 2x. Let's go ahead and set each of these factors equal to 0. And I get two answers, negative 2/9, positive 1. Again, this is an even root problem. Our index was 2, so we have the potential for extraneous solutions, so we're going to have to check our answers again. So we're going to replace x in our original problem with negative 2/9. And since 3 is 3 over 1, I can rewrite this as by multiplying top and bottom by 9. So I have negative 2/9 plus 27/9 equals negative 2/3 minus 1, which is really 1 over 1. So again, I can multiply by 3 to top and bottom. And I get square root of 25 over 9 equals negative 2/3 minus 3/3. Well, the square root of 25 over 9, square root of 25 is 5, square root of 9 is 3. On the right-hand side, negative 2 minus 3 is negative 5 over my denominator of 3. And you can see 5/3 does not equal negative 5/3. Those are not equivalent. So we get a false statement, which means x equals negative 2/9 is extraneous. And now I got to check x equals 1. So I'm going to plug x equals 1 into my original equation. And square root of 4 is 2. 3 times 1 is 3 minus 1 is also 2. So this is a good answer since this gave us a true statement. X equals 1 is the only answer that works for part A. Looking on to part B, we have a cubic root for the first time, and it says 4 plus cube root of x minus 6 equals 2. Again, I need to isolate the radical, so I'm going to move this 4 over. And I get the cube root of x minus 6 equals negative 2. To get rid of this cube root, I'm going to raise both sides to the power of 3. Negative 2 cubed is negative 8. To solve for x, I'm going to add 6 to both sides. And I get x equals negative 2. And since this is a cube root problem, it's an odd index. I do not need to check for extraneous solutions. So x equals negative 2 is a good answer. However, it's a good rule of thumb or good practice to always check your answers, just to check in case you possibly made a mathematical error. So I'm going to go ahead and check just to make sure. So I'm going to plug negative 2 in for x into my original equation. Negative 2 minus 6 is negative 8. We know that the cube root of negative 8 is negative 2. And 4 minus 2 is 2. And it works. So that is a good answer. Moving on to example 2, we got solving a radical equation containing now 2 radicals. Whenever there's more than one radical in the equation, you're going to need to isolate one of the radicals first. So let's move the second radical over to the other side. And I get the square root of 2x plus 3 equals 4 minus the square root of x minus 2. We can square both sides. 2x plus 3 equals 4 minus the square root of x minus 2 times itself. We'll have to FOIL the right-hand side. That will be 16 minus 8 square root of x minus 2 plus x minus 2. Now, again, you'll see that we have a radical remaining in this problem, so we're going to have to now isolate this radical. So I'm going to subtract 16, add 2, subtract x. And I get x minus, let's see, 3 and 2 is 5, minus 16 is minus 11, equals negative 8 square root of x minus 2. Let's go ahead and square both sides to get rid of that radical. And I get x squared minus 22x plus 121 equals 64 times x minus 2. Clean this up. I got x squared minus 22x plus 121 equals 64x minus 128. Since this is a quadratic equation again, I need to move all of my terms over to one side. So I'm going to subtract 64x as well as add 128. And I get x squared minus 86x plus 249 equals 0. This is a quadratic equation. We can go ahead and factor this. Now feel free to use your calculator if you need to, but I need to come up with two numbers that multiply to 249 and add to negative 86, which will be negative 83 and negative 3. So I can set these factors equal to 0, and I get two answers. X equals 83, x equals 3. And if you look back at the original problem, we're dealing with square roots, which have an even index, which means there's, again, potential for extraneous solutions. So I'm going to need to check my solutions. So we're going to start by checking what x equals 83. I'm going to plug 83 in for x into the original equation. Two times 83 plus 3, that's going to be the square root of 169, plus the square root of 81, has to give me 4. Square root of 169 is 13, square root of 89 is 9, 13 and 9 is 22, which does not equal 4. So again, since this was a false statement, x equals 83 is an extraneous solution. Let's go ahead and check x equals 3. Square root of 6 plus 3, that's square root of 9 is 3. Square root of 3 minus 2, square root of 1 is 1. 3 plus 1 is 4. That is a good answer. So the only solution that satisfies this original equation is x equals 3. Let's go ahead and move to the try it on your own. Two practice problems, part A and B. I'm going to go ahead and zoom back in on this. Let's change my color. And again, you'll notice in this part A, I have two radicals in the equation. I need to isolate one of the radicals, so I'm going to subtract the second one over. So I have square root of 3x plus 7 equals 1 minus the square root of x plus 2. I can get rid of this radical by squaring both sides. So I get 3x plus 7 equals 1 minus the square root of x plus 2 times itself. We're going to need to FOIL the right-hand side, and that will be 1 minus 2 times the square root of x plus 2 plus x plus 2. And again, you'll see that I have a radical remaining in this problem, so I'm going to have to now isolate that radical. So I'm going to subtract 1, subtract 2, subtract x, and I get 3x minus x is 2x. 7 minus 1 is 6, minus 2 is 4. Equals negative 2 times the square root of x plus 2. So I can get rid of that radical by squaring both sides. And I get 2x plus 4 times itself. Equals negative 2 squared is 4 times x plus 2. I'm going to need to FOIL the left-hand side. So I get 4x squared plus 16x plus 16 equals 4x plus 8. Again, I need to solve this quadratic equation by moving all of my terms over to the one side. So I'm going to subtract 4x and subtract 8. So I get 4x squared plus 12x plus 8 equals 0. I can factor a 4 out of this problem. Get rid of the 4 by dividing both sides by 4. X squared plus 3x plus 2 equals 0. Factor this into x plus 2, x plus 1. And I get two answers. X equals negative 2, x equals negative 1. Again, since there are square roots in the original problem, that's an even index, which means that there's potential for extraneous solutions. So let's go ahead and check our answers. Again, I'll start with negative 2, so I'm going to plug that into the original. 3 times negative 2 plus 7 plus the square root of negative 2 plus 2 has to equal 1. Well, 3 times negative 2 is negative 6, plus 7 is 1, so I have the square root of 1 plus the square root of 0 equals 1. Square root of 1 is 1, square root of 0 is 0. We get 1 equals 1. That's a good answer. So we know x equals negative 2. Works. Let's check negative 1. 3 times negative 1 plus 7 plus the square root of negative 1 plus 2 has to equal 1. So 3 times negative 1 is negative 3 plus 7 is 4. So we have the square root of 4 plus square root of 1 equals 1. Square root of 4 is 2 plus 1 equals 1. 3 does not equal 1. So that is a false statement. X equals negative 1 is extraneous. So the only answer that satisfies part A in the equation is x equals negative 2. All right, we got one more problem. For part B, we have the square root of 2x plus 5 equals 2 times the square root of 2x plus 1. This radical is already isolated, so let's get rid of it by squaring both sides. 2x plus 5 equals 2 times the square root of 2x plus 1 times itself. We're going to need to FOIL the right-hand side. So 2 times 2 is 4 times 2x plus 2 times the square root of 2x plus 2 times the square root of 2x plus 1. 2x plus 5 equals 8x plus 4 root 2x plus 1. Again, we have a radical remaining in this equation, so we're going to need to isolate that radical. So I'm going to begin by subtracting 1 to the other side, subtracting 8x to the other side, and I get negative 6x plus 4 equals 4 root 2x. Square both sides to get rid of the radical, and I get negative 6x plus 4 times itself equals 4 squared is 16 times 2x. So that's 36x squared minus 48x plus 16 equals 32x. We can go ahead and subtract 32x to the other side. And we get 36x squared minus 80x plus 16 equals 0. And then I can go ahead and divide all of this by 4. So 9x squared minus 20x plus 4 equals 0. Factor this. And I can factor this into 9x and x. To get 4, I'm going to try 2 and 2. They both need to be negative. And I get x equals 2/9. X equals 2. And I'm running out of room, so I'm going to let you check this one on your own. Since, again, there's square roots, I have an even index, so I would have to check for extraneous solutions. And you would see that x equals 2 does not work. It is extraneous. But x equals 2/9 does work. So I hope you enjoyed our lesson. Good luck with the practice problems today.